to be considered a slave server, and it's going to store the details of this information in the linuxcbt.internal.db file. It's also common to store the file in the slaves subdirectory to show that files that are in this directory are considered slave zones or DDNS zones. But if you wanted to, you could store your zone files in a different directory, so long as named has the permissions, both with SE Linux and standard Linux legacy permissions, to write to the directory in which you'd like to store the zone file. You should have no trouble, little to no trouble. With that said, let's save the changes. And we have avoided, as a result of copying the configuration file, having to disable anything related to DDNS keys or TSEC or any security features. And now name.conf has been updated, so we need to get an instance started. This server will become a caching only, as well as a secondary server for the zone linuxcbt.internal once we've started it, and we'll confirm that it's able to query the remote server or the master server for the zone linuxcbt.internal using the dig utility. So with that said, let's start the named daemon using service named start. This will load the various zones. So we've modified it. And D, start named service using service named start. And for E, or for the next step, we should ensure that the named service starts whenever the system reboots using checkconfig. So checkconfig 3.5 named on. And we'll follow that up with a checkconfig list named to be sure that it will start when the system reboots. So named is running. A psef grep named will reveal as such. And then we'll dig from the remote system linuxcbt serve 4 to linuxcbt serve 1. Dig at 192.168.75.10 any of the records defined in the hosted zone. And there you see the query has executed successfully. We should also update the primary or master server's version of the file to include the new name server. So update var named linuxcbt.internal.db to reflect new name server. Let's find the window on the primary, which is this system, and we'll nano var named linuxcbt.internal.db. We'll move the serial number up by 1 and include a new name server line using Control-K, Control-U to paste, and the new server is linuxcbt serve 1, for which we already have an A record, so there's nothing else for us to do. Let's save the changes and restart named. We'll kill all, named, psef grep named, and then service named start. psef again shows that it's running, and then on the remote system we should see, let's navigate into var named. Let's navigate into slaves. We should see that the linuxcbt internal file has been updated. And there we see it has been. It has the latest serial number, 03, and it also has the new record for the new name server. So we've got two name servers defined. So the files are being, or the slave file is being updated by virtue of the slave relationship. Now, as it currently stands, there are no security measures in place to ensure that other rogue or other non-authoritative DNS servers synchronize our DNS information, which is why in the security section we'll lock down the replication process, the primary to secondary replication process. So we've set up primary, secondary, and again, either server can play the role of primary or secondary. Simply define the zone. Let's set up our next task to do exactly that. create a primary zone on the quote-unquote secondary server. There's really no such thing as a secondary server with DNS, but there is, however, a server that functions as a secondary zone holder. So, on this secondary server, we'll create a zone for linuxcbt.external. Once that's in place, we'll then replicate it to what is considered to be the primary server. Let's navigate to the remote system, or in this case the local system, linuxcbt serve 1. We'll navigate to etc and then modify name.conf. We'll navigate to the linuxcbt.com section, .internal section that is. We'll cut this entire block, then paste it twice, making changes to the second instance. We'll label this second internal zone, but in this case, instead of being slave, we'll be the master, and instead of referencing a masters or master, one or more masters, we'll simply comment the line out and change the directory from slaves to just var named, and change the file name from internal to external. But before we restart name, we'll copy the internal file to the external file and then just make some minor changes. So name.conf has been updated. And let's just double check one other thing. We've omitted one item, and that is the name of the zone. They should not be duplicated. Now name.conf has been updated. So the first thing is create a zone for linuxcbt.internal in etc name.conf. Second step, copy/create linuxcbt.external.db zone file. So you can create it from scratch, or copy and paste items off the web, or from your existing DNS servers, or just copy an existing file. So on this server, we'll copy linuxcbt.internal.db. This came over from the original copy to external. We'll then modify the external file, changing wherever we find internal, so you can use your search or replace feature of your editor to make this a quick process, or make the changes one at a time, as we're doing here. So wherever internal is referenced, we now reference external. And the same records will suffice. Save the changes, and now we have a zone file for linuxcbt.external. So on this host, if we attempt to restart the named daemon, it'll restart with a new zone. Using service named restart, we'll cause the new zone to load. We'll pscf grep named, it's running, and now let's query it from a remote system such as serve4 to be sure that it's serving records from the external zone, the linuxcbt.external zone, as opposed to, or in addition to, the internal zone. We'll use dig at 192.168.75.10 www.linuxcbt.external, and it should resolve, and there it does. Ditto for internal. Perfect. And it shows the list of name servers. Now, we have not set up linuxcbt serve 4 to replicate the information. So our next step is to set up 4 to be a slave for the zone linuxcbt.external. So to do so, again, we'll modify etc name.conf. We'll find the area which contains linuxcbt.internal, cut the entire block using Control-K and then Control-U to paste. We'll relabel this comment, just to be consistent, as second, but instead of type master, this now becomes type slave. The file name changes, the zone name changes from in to X, and we need to reference masters or one or more server which contains the master zone information, and that's 192.168.75.10, terminated by a semicolon. Now Linux CBT Serve 4, after we restarted named, will function as a slave server. In fact, let's just keep with convention by ensuring that the slave file is stored within the slaves subdirectory. So that'll be stored in slaves /, and then we'll restart the name service. We'll kill all named, psef grep I name to be sure it's no longer running, then service named start. Echo of the exit status. It looks clean. Let's navigate now to var named slaves, where we'll see the Linux CBT external file, and if we cat the contents, we'll see it includes various items. This means that from the remote system, if we perform a dig as a client would at 192.168.75.199 for www.linuxcbt.external, it'll work. And there you have it. So we've set up primary and secondary between the two hosts. Again, we have two systems that we're working with, a VMware instance, which is referenced by this physical system, a SUSE box running a Red Hat VMware instance known as Linux CBT Serve 4. We've also got Linux CBT Serve 1, which is a standalone box, both running Red Hat Enterprise 5, both functioning as primary as well as secondary DNS servers for two different domains, linuxcbt.internal as well as linuxcbt.external.